Hello everyone, my name is Muhammad Haikal bin Hassan. Today we will start by understanding two fundamental concepts in physics and mathematics, vector and scalar. A vector is a quantity that has both magnitude and direction. For example, displacement, velocity and force are all vector. On the other hand, a scalar is a quantity that has only magnitude but no direction, like distance, speed, or temperature. This concept forms the basis for many mathematical operations and real-world applications. Let us now dive deeper into the one such operation, that dot product. Now, let's define the dot product. Dot product consists of two vectors A and B, and the angle between them is theta. The dot product is a way of multiplying two vectors to produce a scalar. Mathematically, the dot product of A and B is defined as modulus A times modulus B cos theta when both vectors are non-zero. 0 if either A or B is the zero vector. This means the dot product depends on the magnitude of the vector and the cosine of the angle between them. It plays a curious role in physics, geometry, and engineering, help us to understand project, work done, and
Hi, my name is Nazrin and I will continue our presentation for today. So today I will talk about the theorems in vectors. There are three theorems that I will talk about today, which are the theorem of dot product, theorem of angle between two vectors, and theorem properties of dot product. The first one is the theorem of the dot product. The dot product of two vectors is a scalar quantity calculated by multiplying their corresponding components and summing the results. If vector A has components of x1, y1 and z1, while vector B has components of x2, y2 and z2, then the dot product is given by A dot B is equals to x1 times x2 plus y1 times y2 plus z1 plus z1 times z2. This operation helps us to understand the relationship between two vectors, including their angle and magnitude interaction. Now moving on to the angle between two vectors. The angle between two non-null vectors can be determined using the dot product, and here's how it works. If A dot B is more than 0, the angle will be an acute angle, and if A dot B is less than 0, the angle will be an obtuse angle, and if A dot B is equal to 0, the vectors are perpendicular and the angle is exactly 90 degrees. This relationship helps us to understand the geometric alignment between vectors, and this is crucial for fields like physics and engineering. Next, let's discuss the properties of the dot product. If A, B and C are non-null vectors and K is a scalar, the following properties hold. The first one is called commutative property, which is A dot B is equals to B dot A. The next one is distributive property, which is A dot B, which is A dot the sum of B and C is equals to A dot B plus A dot C. The third one is scalar multiplication, which is K times A dot B is equals to KA dot B, and it is also equals to A dot KB. The next one is magnitude relation, which is B dot B is equals to the magnitude of B square. And the last one is zero vector property, which is A dot 0 is equals to 0 dot A, where 0 is a null vector. These properties are fundamental when working with vector operations in various mathematical and physical applications.
Hello, my name is Brandy. Now I want to talk about application of vectors, work done by a force. Work is a fundamental concept in physics that measures the energy transfer when a force is applied to an object, causing it to move in the direction of the force. The mathematical expression directly tied to the dot product of two vectors, the force applied and the displacement of the object. This relationship provides a concise and effective way to understand how forces interact with motion in real-life scenarios. This is the explanation of work equals to force times to distance, which is equals to modulus F times to modulus D times to cos theta. Magnitude of force. The stronger the force applied, the greater the potential work, assuming displacement occurs. Magnitude of displacement. The distance over which the force affects the total work. If there is no movement, which is D equals to 0, no work is done, regardless of the force applied. Angle. The cosine factors determines how much of the force contributes to the displacement. When theta is equals to 0, which is force and displacement are parallel, cos theta equals to 1. Maximum work is done. If theta equals to 90 degrees, force and displacement are perpendicular. Cos theta equals to 0, no work is done. If 90 degrees less than theta less or equals to 180 degree, force act opposite to displacement. Work becomes negative, indicating energy is removed from the system. This is the example of application for vectors, which is dot product. Calculate work done when force is at angle to displacement. The applied force and displacement can be at an angle to each other. For example, a student pushes a lawn mower forward with a constant force of 48 Newton, force of 7.5 meter. The angle between the force and the displacement of the lawn mower is 32 degrees. Calculate how much work is done on the lawn mower by the student. So, this is the diagram for the question just now. The given information is force equals to 48 Newton, distance is equals to 7.5 meter, and theta is equals to 32 degree. The required is work. Analysis. The work done on the lawnmower by the student depends only on the component of the direction of the mower's displacement. Use the equation for work, which is work is equals to force times to distance times to cos theta. Force and distance are at an angle of 32 degrees to each other. For the solution, work is equals to force times distance times to cos theta. We submit the information, which is 48 Newton, 7.5 meters, and cos 32 degrees. So, the answer should be work equals to 3.1 times to 10 power of 2 joule. So, for the statement, the student does 3.1 times to 10 power of 2 joule of work on the lawn mower.
Hello, my name is Nora Kalaris and I will talk about the importance of work in energy transfer. Work is directly linked to energy transfer in physics. When positive work is done on an object, energy is added to it, often increasing its kinetic energy or potential energy. Conversely, when negative work is done, energy is taken away, slowing down the object or reducing its potential energy. So, in the conclusion, the concept of work done by a force grounded in the dot product offers a versatile tools to analyze energy transfer in diverse scenarios. By understanding how force, displacement, and angle interact, scientists and engineers can design systems that efficiently utilize energy, from constructing buildings to optimizing transportation and manufacturing processes. So that's all from us. Thank you.